review, I want to go over the first few digits of decimal and their equivalent binary form. So actually, yeah, I'm going to switch this. If you keep it the same, it's all fine. And we're going to go, that's about it. That looks good. So 0 in decimal is what in binary? So what is the equivalent of 0? So we want to go 0, 1, 2, 3, 4, and we'll add one more, 5. Let's count to 5 in binary. Okay? What do I get? What is 0?
0.
Good. What is 1?
1.
1. Okay, so those first are always going to be the same. That's nice because binary goes there. All right, now the tricky one. What is 2? Can we recall from yesterday?
11.
Wrong.
10.
1, 0. Yes, 10. 1, 0. I like to call them by 1, 0 versus 10 so you don't get confused. All right, Elian. What's 3?
11. 11.
1, 1. All right. Tougher now. What's 4? What's 4?
No idea. 1, 0, 1 now.
Anybody? No, you can only use 1s and 0s. So since you want that next number to be a 2, it means you have to go to 3 digits. So we've done both the 2 digits. There we go. Dwell. 1, 0, 0. And for fun, what's 5? Yeah, 1, 0, 1. And then we would go to 1, 1, 0. Well, actually, we might as well just go through at least the 3 digits here. 6 and 7. We would get 1, 1, 0. And then finally 1, 1, 1. Now, you should, I believe your homework should only go up to 3. We talked about this in yesterday's. 1 plus 1 plus 1. So, because, and what I'm saying by we did that yesterday, as such, 1 plus 1 is what? It's 2, but, so 1 plus 1 is? In binary?
10.
1, 0. Make sure you memorize that one. 1 plus 1 plus 1 is?
11.
Good. 1 plus 1 plus 1 plus 1.
It's 100.
It's 4, yeah. So 1, 0, 0. These are about the main ones you would need to memorize. I don't think in today's homework this is as hard as the addition will get in terms of those ones. You might get a 1 plus 1 plus 1 plus 1. I don't think I gave you any problems that's going to happen because that means we have to have 4 rows of 1 in there. So this one's a little bit trickier. I hopefully I didn't, but I'll do an example I think that has that. So in multiplying binary, is just like normal multiplication. You need to, the key here is to shift, however you want to word it, a digit place each digit we move to. Now, also important is that you're multiplying by 1 or 0, and multiplying by 0 equals 0, and by 1 equals, and I'm going to put it in quotation, itself. After all, and I'm going to call them subsums found, you just add them. Okay, so we're going to do like normal multiplications. Okay, so there's nothing different than the multiplication that if you were to multiply. And so first off, let's just make sure we know how to do normal multiplication. So multiply the following decimal. All right, a decimal does not mean that there is a decimal point, as we have hopefully now known. Okay. So the example here is 58 times 62. All right. What do I do first?
8 plus 2.
8 times 2 is?
16.
So I bring the 1 over here, and then I have 6 down there, and then I do what?
1 times 5.
No.
I don't remember how to multiply like this.
Can someone help?
I don't.
5.
I'm gonna reveal something to you. I never remember how to do it.
So
I never knew how to do this. Okay.
So we do 5 times 2. All right, well, this multiplication will be even easier though, so for you. So don't worry about it. So 5 times 2, 2 times 5 now, plus the 1, which gives me 11. And I could just put the 11 because there's no other numbers to multiply. Now, and we've used that one, so I cross it out so I don't get confused on it. Now what do I do?
You're gonna multiply 6?
Before that. You're correct, but before we multiply by the 6, what do we have to do? What's the next step in multiplying? Anybody?
Put a 0 on it.
I think you're gonna.
Yeah, there we go. Thank God, Dwella. We add a 0 because we're moving over a term. So we sometimes call this as shifting. So we always this is the shift piece right here. And now we multiply by the 6, okay? So we move over to placement. So 8 times, thank you guys, 8 times, or 6 times 8 is 48. I carry the 4. Next up, 6 times 5 is 30.
Plus 4.
Plus 4 gives me 34. Boom. All right. Now we add these together. And that gives me, I add straight down, that's 6, 9, nothing, no, I don't have to carry anything over here, 5, and 3. So there's my answer. Now, of course, if this was like a 2 and this gave me like a 10, then I would have done a 1 and a 0, something like that. I would have still carried in terms of the addition. Now, there's other courses. Maybe you come from a country or an educational system where you learn some tricks to your multiplications, but this is more of just the traditional method of multiplication, and it's the same process that we're going to follow with what we're going to do today. And in essence, it works like you were exactly the same as multiplying, at least in the first step, will be exactly the same as in the decimal form. So now let's talk about binary multiplication example. So multiply the following, and I'm telling you they're binary numbers. I'm not going to note them. I could note them with a little sub 2 in there, but I'm not. I'm telling you they're binary. And my first example is give me a 3-digit binary.
101.
101, and we're going to multiply that by, let's go 1 1. Okay, now this is equivalent. This is equivalent to multiplying 5 times, what is it, 3? Which is 15, of course. And you're like, well, why don't I just do 5 times 3? Well, the whole purpose is to understand how binary works and how computers and the number systems can work. And when you get to much more difficult values, you can see why the process is a lot easier. So in doing this, we're going to do the same properties. This is the same. We're going to multiply it by 1. The nice thing about multiplying by 1 is I get exactly what I have. So it's 1 times 1 times 0 times 1. So I get 1, 0, 1. And that's for multiplying this 1 right there. Okay. I then add a 0. That's the shift. Everything is the same so far. And then I multiply by this one. Well, that gives me 1, 0, 1. So basically, whatever I see on top, I'm going to get the same thing. And I can really just think about it. I'm copying it every single time, but I keep shifting over 1-digit place every single time. Of course, we'll talk about what happens when you multiply by 0, because if we're multiplying by 1, that's what happens. And then we add this down. So 1 plus 0 is, and remember it's binary. Well, this one turns out very nice.
1 plus 0 is 1.
Okay, no need to carry anything. 0 plus 1? 1 plus 0?
1.
And 1. So my answer is 1, 1, 1, 1. And if you recall, 1, 1, 1, 1 is the same thing as 8 plus 4 plus 2 plus 1, which is 15. Now, I'm not asking you to do the part on the right. All I'm asking you is to do this. You don't have to check your work, okay? I'm not asking you to go forth and check your work and something like that. All right. Let's go to a 4-digit example. Somebody give me a 4-digit binary number mixture of 1s and 0s. Starting with 1. 1, 0, 0, 1. Okay, and we're going to multiply this. Let's multiply by a 3-digit binary number. A mixture of 1s and 0s. Starting with a 1. 1, 1, 0. All right. Thank you, Isis. So, first step, we're multiplying by 0. Oh, that's nice. 0, 0, 0, 0. Next thing we do, we drop down that 0 because we're going to shift over a placement, and we're going to multiply by 1. Oh, that's nice. So I'm going to basically, all I got to do is copy this 1001 right there because I'm multiplying by 1. But don't forget to shift with that 0. So that gives me 1, oops, I got to choose one. 1, 0, 0, 1. Then add 2 zeros because I'm going to move it shift over one more time. And now I'm going to multiply by 1 again, which gives me 1, 0, 0, 1. This one's also a nice one as well. There's nothing that's going to be, there's no 1s and 0s that are, there's no 2 1s that are above each other. So this one's also a very easy addition to finish, I get on the far right 0 plus 0 plus 0. Zero plus 0 plus 0.
0.
0 plus 1 plus 0.
1.
0 plus 0 plus 1.
1.
0 plus 0 plus 0.
0.
1 plus 0.
1. 1.
And 1, 1. And that's my answer. Boom, that's it. That's all I'm asking you for. 1, 1, 0, 1, 1, 0. Just like Isa says, typed it in the full answer. Damn. All right, let's get bigger. Let's get dangerous. I'll do this next one. 1, 1, 0, 1, 1. And we're going to multiply that by 1, 1, 1. We'll actually make that a 0 right there. Let's go 1, 1, 1, 1. Why not? All right. What do I do first? Can someone help tell me what I do first?
Multiply by 1.
Multiply by 1. Okay, so I'm going to get what?
1, 1, 0, 1, 1.
And I'm always, when I'm asking for them, I'm asking from the right to left. Perfect. Add the 0. And then I get
1, 1, 0, 1, 1.
good.
You add another 0. 1, 1.
I add 2 zeros. Yes. Okay, you gotta add 2 zeros. Careful with that. Now, we're like as you're going, Mark. 1, 1, 0, 1, 1, and then what do we do?
3, 0.
3 zeros.
You add another 0.
Yeah, so it's a total of 3 zeros, and 1, 1, 0, 1, 1.
And 1.
Okay, so this one is going to get a little bit more complicated. This should be good enough for us for our examples for the day. All right, starting from the far right. 1, 0, 1 gives me 1, good. 1 plus 1 plus 0 plus 0.
2.
No, we're binary. We're in binary.
2. Oh.
10. There we go. 1, 0. That's the hard part. So it's a 0, and then a 1 comes up here. We carry the 1. Isis is jumping ahead. I get 1 plus 1, 1 plus 0 plus 1 plus 1, which is 1 plus 1 plus 1, which gives me, Isis said it, 11. So I carry the 1. Ooh, this is that tough one. 1, 1, 1, 1. 1 plus 1 plus 1 plus 1. You got to go to
8. Which one was 8 in binary? 1, 0, 1?
No, it's 4 in binary. So we have to go in. We've already gone 1, 1. So after you fill out all the spaces, always remember that your next number up just adds an extra digit, and it's always 1, 0, 0. So after you go from 1, 1, 1, 1, 1, and all the current placement values are 1, then your next number always is just one more digit, and it's always going to be 1 with the extra digits, all zeros. So what do I get here? I've already used the 1, 1, which is 2 digits. So my next number will be 3 digits, with the first number being 1 and the rest 0. So what do I get? I get 1, 0, 0. So now here's the tricky part right here. So it's a 0, and then it's carry the 10. Carry the 1 and a 0. Now when I carry the 1 and a 0, the 0 goes here and the 1 goes over here. So it's 1, 0, 0. All right, that's going to be the toughest thing. And I think it might happen once on your homework, if not at all. So it's 1, 0, 0. So I put the 0, and then the 1 goes even a further place value. All right, now let's continue adding. 0 plus 1 plus 1 plus 0 plus 1 is 11. Yep, so there's the 1. Carry another 1. So I have to carry another 1. So now I have 2 extra 1s that are in that spot. And I have 1 plus 1 plus 1 plus 1. So it's 0 again. So 0. Let me put that a different color. A 0 and a 1. Then it's 1 plus 1. 10. So 1 0. And 1 plus 1 plus 1. 11. And there I go. That's as tough as it gets when you have to carry it for twice. So never happens in regular multiplication or regular addition when you have to carry twice. That's as difficult as it gets when you get 1 0 0. So when you get that 4, when you have 4 1s in the same row or same column of addition, that's the trickiest place. So you have to carry twice. Okay, so just in terms of the notes. How do we feel?
I feel weird.
You feel weird, okay? How do you feel about the math?
Oh, I feel cool.
Oh, I feel cool with the math. All right, it's hard. It's a different. So, and to go with Mark Diane's response, you said it's hard, and I want you to kind of think. It's not that it's. Hopefully that you don't see that it's hard, but it's different. It's different.
I don't think it's hard. I'm just a little slow.
Oh no, yeah, but it's just a different way of thinking. And this is why I can tell you this. I never was able to get an education in stuff like discrete mathematics. And so when I was by the time I saw something like this, I think I was a junior in college. I was all the way junior, and I'm talking a junior at MIT. I had to take, and I enrolled in a discrete mathematics class. And at MIT, even though they're teaching you the subject for the very first time, the belief is you already know it. It's kind of dumb with that. So I saw it, I freaked out, and I was like, nope, this is not for me. I have never seen this in my life. And they were jumping like, what we were doing like in week 4 was like day 2. It's like they covered like the first 4 weeks of like what we covered in like by the first 2 days. That's how crazy it was. And I was like, all right, I never was able to think differently. And one of the things I hope that you learn in this course of discrete mathematics is how to think differently. When we get into our next course, if you're still with me, a lot of that's going to be on logic, and a lot of it's going to be based on the idea of how do we think differently, thinking outside the box in terms of just normal counting. This is kind of almost like a segue into that next course. But a lot of it is just like, hey, I am so used to thinking 1 plus 1 is 2. All right. Why? Why does 1 plus 1 equal 2? No, 1 plus 1 equals 10. And you can actually show somebody and tell them, did you know 1 plus 1 equals 10? And they'll be like, no, that's not true. And you're like, you know what? It is. In binary, 1 0 is equivalent to 2, and therefore 1 plus 1 does equal 10. And these are kind of the things in terms of the thinking systems. So I hope it piques your interest. I don't think we need another example, do we?
You
tell me.
No. It's cool. Back in Dominican Republic, we were learning about adding, multiplication, division, like that simple thing that is supposed to teach you in 3rd grade. I've been learning the same thing in Dominican Republic from 1st grade toward 7th grade. The same thing.
And that also happens a lot, even in United States, even at BCLA. Sometimes you're learning the same thing in 9th grade, you learn in 8th grade, you're learning the same thing in 10th grade, you learn in the 9th grade.
But you know what you said about think differently?
Yeah.
Like, it doesn't exist we don't have something like this in mathematics in Dominican Republic. It doesn't exist.
It's not in your curriculum. Yeah, it's definitely not in your curriculum.
No. and I tell my, oh mom, look at this. Mr. Gutierrez gave this, and like, what the hell is this?
Well, I'm glad to hear that. So, it's practice with it. Like I said, I don't think they're good. I believe I didn't make a problem. I think the very last problem, problem 8, gets to something close to this size. I don't think any of the other problems will have a double carry. Maybe the very last problem. I can't remember it off the top of my head, but I believe all of the other ones should be rather straightforward. You might have to carry the 1 to make it 1 0 for the 10. But yeah, and if just to confirm, what we're doing here, basically what we've done is we've multiplied, what is this? 1, 2, 4, 8, 16 plus 8 is 24 plus 3. We multiplied 27 times 15. So we multiplied 27 times 15. And if you think about it, and you think about computers, and you think about how things work, they don't like to see 27 times 15 because then you have this, 35 and tracking things. And a lot of the way these computers do it, in a way that they were learned to be able to do it, is once again, it's about these on-off switch. And so when a computer gets 27, when your calculators get 27, and especially in the beginning, it turned it into 11011. And then it says, all right, I'm going to multiply this by 11111 or 1111, which is 15. And everything just, all right, I just shift over, add down, here's my new number, boom, this is what it is back in decimal form. So a lot of times what computers do is they take this decimal, put it into binary, spit it back out into decimal form, especially in the early days, in the early introductions of computers. So that's what I have for you today. The rest of the class is asynchronously. I didn't want to take even as long as I did, but I thought we had some good conversations. Thank you, Mark, Diane, Eliana, Brianna, all Abdullah, everybody that participated in class verbally today and through the chat. It is a 3-day weekend, so do enjoy. I will see you on Tuesday. All right, Tuesday. Take care.